Welcome students. Today we're going to do lesson 10.7, elapsed time. Today's lesson has the conversions at the bottom of the page here on page 623. You can find number of seconds in a minute, minutes in an hour, hours in a day, days in a week, weeks in a year, months in a year, and then also days in a year. So you can always refer back to this page to help you with your conversions. Most of these should not be new. You've learned them in maybe lower grades, so you can always refer back to this if you forget. First example question says, a computer company claims its laptop has a battery that lasts 4 hours. The laptop actually ran for 200 minutes before the battery ran out. Did the battery last 4 hours? So first, we need to look that we know 1 hour equals 60 minutes. So we're going to convert our 200 minutes into hours and minutes. And we can use horse to fly and fly the horse for this as well. So we have minutes, which we know is smaller than an hour. It's less time. So we're going from fly to horse. So we're going to go ahead and take 200 and divide it by 60, because there are 60 minutes in 1 hour. So if we take 200 and divide it by 60, 60 goes into this 3 times, because 6 times 3 is 18, add a 0. Subtract, and I get 20. I didn't use the zeros trick where we cancel zeros out, because I do want a remainder on this to be the actual remainder, because we need to know how many minutes are going to be left over. So for this, we get 3 remainder 20, which means 200 minutes are 3 hours and 20 minutes. So the battery life of the laptop ran for 3 hours and 20 minutes. That is less than 4 hours. So since 3 hours and 20 minutes is less than 4 hours, the battery did not last as long as the company said. Did not last as long. Jill spent much of her summer away from home. She spent 10 days with her grandparents, 9 days with her cousin, and then 22 days at camp. How many weeks and days was she away from home? So first, we have 10 days, 9 days, and 22 days. We're going to add those numbers up. You could go 10 plus 9 plus 22. 9 and 2 makes 11. 1 plus 1 is 2, plus the other 2 gives us 4. So we know Jill was away from her house for 41 days. But we want to turn this into weeks. So if we're going from days to weeks, days is shorter, we're going to divide. And there are 7 days in 1 week. So we're going to divide by 7. So we take 41 days, divide it by 7. 7 goes into 41 5 times, because 7 times 5 is 35. And if I take 41 minus the 35, I should get 6 left over. Again, if we work this out, 41 divided by 7 should be 5, because that's 35. Subtract this, and you should get 6. So we have 5 remainder 6. That means she was away from her home for 5 weeks and 6 days. 1 more day, and she would have made it to 6 weeks. On the next page here, you're going to see us try to convert elapsed time. And what that means is we want to figure out how much time has passed from the beginning time to the end. Now, we may also be given the beginning and then how long an event happened, and you have to find the end time. We could be given the end time and also how long the event happened, and you have to find the beginning time. So there's three ways that you can work some elapsed time. But the biggest thing is you just need to make sure that we are counting hours and counting minutes very carefully as you go. On this example here, Monica spent 2.5 hours working on her computer. If she started working at 10:30, what time did Monica stop working? So we know that she spent 2.5 hours. And an hour is 60 minutes. So half of that is 30 minutes. We haven't worked with fractions quite yet, but let's look at this clock to just review before we get started. A half an hour, first of all, each one of these numbers on a clock are going to represent 5 minutes because there are 12 numbers and 60 divided by 12 is 5. So every one of those numbers represents 5 minutes. So first of all, just a quick review. If I cut this clock in half, the 6 would represent 30 minutes. If I cut this into fourths, 1/4 of an hour, 1/4 of an hour is going to equal 15 minutes. And the 3/4, this is 15, this would be 15, so 15 more. 3/4 of it, the 9, is going to represent 45 minutes. Now, you may hear adults say a quarter past a time, so a quarter past 2, which means in fractions, 1/4 is like a quarter. Okay, 1/4 out of 4. Okay, so 1/4 is a quarter. So if someone were to say a quarter past 2, they would be talking about 15 minutes past 2 or 2:15. Now, they may also say a quarter till 3. A quarter till an hour means we are 1/4 away or 15 minutes away from the next hour. So we're a quarter until 3 o'clock, which means we're 15 minutes before that. We would be at 2:45. So just in case you hear someone talking about a quarter past or a quarter till a time, you would know 15 minutes past it or 15 minutes before that next hour. Now, back to our example problem here. We know Monica has spent 2.5 hours working on her computer, which means she has spent 2 hours, and a half of an hour is 30 minutes. And she started at 10:30. We need to know what time she finished. So, if we're starting at 10:30, 1 hour would be 11:30. And again, we're still AM because this is 10:30 AM. We go 1 hour, we're at 11:30 AM. We go 1 more hour, and we're now at 11:30 plus an hour, we're at 12:30. But remember, when you pass 12, both at noon and at midnight, the AM and PM switch. So we were at 11:30 AM, we are now at 12:30 PM. So that's 1 hour plus another hour. There's our 2 hours. The last thing we have to do is add our 30 minutes. 12:30 plus 30 minutes would give us 1 o'clock PM. 1 o'clock PM. So again, back to just kind of looking at this. If you started at 10:30, you can use maybe addition for this, 10:30, and we add 2 hours to that, we would be at 12:30. Then we would add 30 minutes. Now, just remember, when you get to 60 minutes, that is going to give us an extra hour. So the 12 now becomes 1, and we would have no extra minutes. So if you're using addition here, you have to be careful. Remember, when you borrow or when you get to 60 minutes, you have to convert that to another hour. And then once you hit 12, it's going to then change back to 1 and start over. Let's look at the next time here. Robert's soccer team needs to be off the soccer field by 12:15 p.m. If each game is at most 1 3/4 hours long, what time should the game begin to be sure that the team is off the field or finished on time? Remember, we kind of talked earlier that 1/4 of an hour is 15 minutes. So 3/4 of an hour would be 15 plus 15 plus 15, which is 45 minutes. So remember, 45 minutes earlier here, so we're trying to backtrack from 12:15. We have to end at 12:15, and we have to figure out what time we need to start. So the first thing we want to look at is, if this is the time right here, 12:15, when we want to end, we need to go back 45 minutes earlier. Okay, so we're going to work back on the clock 45 minutes. So remember, we kind of divided this into fourths. Here's 15 minutes. Okay, 15 minutes would get us back to 12 o'clock. Another 15 minutes. Okay, so there's 30 minutes would get us back to 11:45. And then another 15 minutes, so giving us our 45 minutes, would get us back to 11:30. Okay? So remember, we're at 11:30. And again, all we did was subtract 15 minutes from 12:15, get us back to 12. Then we subtracted another 15 minutes, which got us back to 11:45. And then another 15 minutes got us back to 11:30. Then we have to subtract one more hour from that. So if we subtract a whole hour from 11:30 and we take an hour off, now we're talking 10:30. So the game should begin no later than 10:30. And remember, if we're finishing at PM, we passed 12, so we had to go back to AM. Now, another way that you could do this is you could use subtraction. We could say that 12:15 p.m. minus 1 hour and 45 minutes, and figure out what time that would be. Now remember, this is PM, and we're going to pass the 12 o'clock mark, so we're going to go back to AM. So we go 5 minus 5. Well, we're going to have to borrow here. So 15 minutes minus 45, you can't do. So we're going to borrow from the 12 and make it an 11. Now, here's the key when you subtract with time. you can't bring over 10 like we normally do. We are bringing over 1 hour. We just borrowed an hour, so how many minutes are in 1 hour? We have 60 minutes in 1 hour. So we're going to bring over 60. So 60 plus the 15 that's there, 60 minutes plus 15 is going to get us 75. So we're going to change this to 75 minutes because we just brought over 60 minutes, which is an hour, and that's what we borrowed from the 12. We borrowed an hour. So we added 60 minutes to our 15 that was there, 75. Now, 5 minus 5 is 0. 7 minus 4 is 3. And 11 minus 1 is 10. And remember, it was PM, but we're working backwards in time. So we cross 12, it goes to AM. 10:30 AM. So you can either count backwards like a clock, or you can subtract and still get the answer 10:30 AM. Let's go to the next page. We are converting minutes to hours. So again, we can use our horse to fly and fly to horse. If you are not sure about which conversion to use, just look back to the bottom of 623 right down here, and you'll find which numbers to use. So 54 minutes equals how many hours? We're going minutes to hours. Minutes are smaller, so fly to horse, divide, of course. And we are dividing by 60 because there are 60 minutes in an hour. 60 doesn't go into this. 60 doesn't go into 54. 60 is going to go into 540 9 times because 6 times 9 is 54. And then we add a 0. That would be 9 hours. Number 2, 8 days is how many hours? So we're going from days to hours. A day is longer than an hour. So this is horse to fly. So we're going to multiply. Number of hours in a day is 24. So we're going to take 24 times 8. 8 times 4 is 32. 8 times 2 is 16, plus 3 is 19. So it will be 192 hours in 8 days. On number 3, we have 110 hours equals how many days in hours? So we're going from hours to days, fly to horse. We're going to divide, of course. And we're going to take our 110 and divide it by 24. Because there's 24 hours in a day. Now, we have to think about how many times does 24 go into 110. So we can try 24 times 3. We can try 24 times 4. That would be 16. 4 times 2 is 8, plus 1 is 9. That's as close as we're going to get because 24 times 5 is 120, and that's too big. So 4 is our number, and we're going to use 96. We subtract. Borrow from this. That becomes 4, and 10 minus 9 would give me 1. So we would have 4 days and 14 hours left. 4 days, 14 hours, which is the same as 110 hours. So when you're converting time, and that could be seconds, minutes, hours, days, weeks, months or years, you just have to look at your conversions and still use horse to fly and fly to horse. For elapsed time, we can kind of think of as a number line, or we can use our subtraction or addition to figure out that time. So let's look at the elapsed times here. If the start time is 9:17 a.m. and the event, the elapsed time here, was 5 hours and 18 minutes, what was the end time? So you could think of it as this way. We could say 9:17, and if you jump 18 minutes for our 18 minutes here, we would have 9:35 a.m. Now there's our 18 minutes. Now we have to go from 9:35 5 hours ahead. So we're thinking 9:35, 1 hour, 10:35. Another hour, 11:35. Another hour, so there's one, there's our second, there's our third. This is going to give me 12:35. And remember, we just crossed the 12 o'clock mark, so we are now at p.m. Another hour, so there's hour number 4. We're at 1:35 p.m. And one more hour, the 5th hour, gives us 2:35 p.m. End time would be 2:35 p.m. So you could use a number line to count your hours that way. We also could use addition in this case because we have our start time. So that would be 9:17. And we're going to add 5 hours and 18 minutes to that. If we add that, we're going to get 35 here. And 9 plus 5 is 14. But we can't have 14 o'clock. So remember, 14 changes when it hits the 12 here. So if we take away 12 from 14, 14 minus 12 hours, right? That's when it changes back. You'd have 2. So at 14, it would be 2:35. And the reason why we have to change it that way by doing the subtraction is, remember, we can't have a 14 o'clock. At 12, it changes. So if it crosses that 12 o'clock mark, you would then just take away 12 from that, and then you would know it would be 2:35. And again, since we crossed it, it was a.m., it is now p.m. Let's look at number 5. The start time is 11:38 a.m. The elapsed time is 3 hours and 10 minutes. Now, you can use addition here, or you can just count. I think it's going to be easier to just count the hours than use addition in this case, so that's what we'll do. We're going to start at 11:38. And I always like to add my minutes first. Some people would rather count the hours first and then add the minutes at the end. That's fine, it doesn't matter. But I always like to get rid of my minutes first. So if I added 10 minutes to 11:38, we know we're going to be at 11:48 a.m. And now I'm done with my 10 minutes. Now I need to count my 3 hours. So if I'm jumping 3 hours, I'm thinking 1 hour is 12:48. Another hour is not 13, remember, it changes, so it flips back to 1:48. And we were at a.m., now we're at p.m. And then one more hour would be 2:48 p.m. And there's our 3 hours, 1, 2, 3. So the end time has to be 2:48 p.m. And it's important to make sure we put a.m. or p.m. because
2:48 p.m. is in the afternoon. 2:48 a.m. is in the middle of the night. And that's two different times there.
Number 6, we don't know the start time.
We know the elapsed time is 2 hours and 37 minutes,
and our end time was 1:15 p.m. So we can start at 1:15 p.m. and count backwards 2 hours and 37 minutes. So first, we're going to count back 15 minutes. It's easiest to get back to the full hour rather than try to subtract 37 minutes altogether. So we're only going to jump back to 1 o'clock. So we're going to jump back to 1 o'clock by subtracting 15 minutes. Now, if we only subtracted 15 minutes, we still have 22 minutes left to take off. So we're going to go ahead and subtract 22 minutes from 1 o'clock. So if we're at 22 minutes, remember 1 hour is how many minutes? 60 minutes, right? So we're thinking, take off the 12, or 1 hour, make it a 12. Now, why did I change my 1 back to 12? Remember, our clock cross is there. So if we're at 1 o'clock, it will cross over to back to 12. I've gained 60 minutes here. So we're doing 60 minus 22, which is going to be, after I borrow, 38. And it was 1 o'clock. Remember, it crossed back to 12. So we're talking 12:38. So if you had 1:15 and you took 37 minutes off of that, you would be at 12:38. Okay? Now, we have to still take off 2 hours of that. So if we're at 12:38 and we go back 2 hours, we would be at 10:38. And we were at PM, we crossed that 12 o'clock mark. We are now at 12:38 a.m. or 10:38, excuse me, 10:38 a.m. Now, you can always check your answer by starting at 10:38, counting 2 hours and 37 minutes, and seeing if you get 1:15 p.m. Let's look at number 7 here. We're again looking for that start time. So we're again working backwards. Okay, so we're thinking subtraction because we're starting at our end time and we're going back to our start time. Now this one's a little bit easier than the previous one, so this one should make a little bit more sense maybe than the last one, because that last one with 37 minutes, we had to cross the whole hour and then we crossed the 12 o'clock mark. On this one, we have 5:30 p.m. and we're only going back 2 1/4 hours. Or remember, 1/4 hours is 2 hours and 15 minutes. So if we start at 5:30 and we take away 2 hours and 15 minutes, we go backwards in time. Now you could just take off 15 minutes from 30, which is, subtract, you're going to get 15 minutes. So if you were at 5:30 and you take 15 minutes off, you would be at 5:15. But then we're going to take 2 hours away from 5, and we're going to get 3, leaving us with a start time of 3:15. And since we did not pass 12 o'clock, we are still PM. 3:15 plus 2 hours gives us 5:15, plus the extra 15 minutes gives us 5:30 p.m.
Now, number 8,
You have a start time of 7:41 p.m. and an end time of 8:50 p.m.
and we have to figure out how much elapsed time happened. How much time is it from 7:41 p.m. to 8:50?
Well, if we look at that, we can just start by putting down 7:41. And I want to get to 50 minutes. Well, 7:41 or 41 to 7:50 is 9 minutes. Should be an N there. 9 minutes. 7:41 to 7:50 is 9 minutes. And then from 7:50 to 8:50, which is the time we're trying to end at, is 1 hour. So if you look, to go from 7:41 to 8:50,
And both of them are p.m.
it is only 1 hour and 9 minutes.
1 hour and 9 minutes. So for elapsed time,
You can do two different ways. You can use
the method where you just kind of count the minutes and then count the hours.
Or you can use the subtraction or addition method, like we've done on this problem here. And we kind of did it in this problem there as well.
But it doesn't matter which method you use. Choose one that you understand and do that. Don't try to use both of them. Just pick the method that you understand the best and use that method.
Last thing here, just
For some extra knowledge here, explain how you could find the number of seconds
in a full 24-hour day. Well, if we would take 24 hours, we could simply just multiply it by 60, because that's the number of minutes
in an hour.
Okay, so we would multiply that by 60. 24 times 60. I'm going to do 24 times 6 and then add a 0. And that would give us 1,440 minutes in a day. And then you need to take that number and multiply it by 60
To figure out the number of seconds, because there are 60 seconds in
every one of these minutes. So we would take 144 times 6. Again, I'm leaving those zeros outside here. I'm just going to drop those two zeros down first. And then I'm going to go 6 times 4. 6 times 4 is 24, plus the 2 would be 26. And 6 times 1 is 6, plus 2 is 8. There are 86,400 seconds in one day.